Okay folks, so today's lesson is on alkenes, so it follows directly on from the previous lesson. Please, if you haven't watched the alkanes video, the previous one to this, the hydrocarbons and alkanes one, go back and watch that one first, otherwise this one will be really throwing you at the deep end. So we're going to start off, as before, with a quick quiz. So what I would like you to do is to pause the video and have a go at these questions. There's only 5 of them. All the answers to these are in the previous video. So just pause it, quickly spend 2 minutes doing it, and I'm gonna restart the video in 5 seconds. 3, 2, 1. Okay, make sure you've done it, okay? Make sure you've done these. So pause it and do them. Right, saturated hydrocarbons only contain what type of bonds? So the answer there is single bonds. So if a hydrocarbon is saturated, they've only got single bonds in them. How many carbons are in ethane? So again, we did this in the previous video, and you've got the prefixes. You've got meth, eth, prop, and bute. We'll do some more work on those today. So that is 1 carbon, 2 carbons, 3 carbons, 4 carbons. So eth. So ethane, so that is 1, 2. So the answer is 2 carbons. Name this compound. Again, using this one. So meth is 1, eth is 2, prop is 3. 1, 2, 3. So this is propane. And that's my daughter on the baby monitor. So I'm just going to pause the video now. Okay, sorry about that interruption. I'm filming this in the evening because I've been at school all day, so I haven't had a chance to, it's the first chance I've had to do it. So if I'm whispering a little bit, it's because I'm trying to keep the noise down because my daughter's room is right above where I'm filming. So where was I? Name this compound. Okay, so it's got 3 carbon atoms in it. So 3 is prop, so it is propane. I'll talk about this second part of the name later on. So we've got ethane and propane. I'll go through that later on in this video. Alkanes are an example of a what series? So the answer is homologous, which I can't spell. H-O-M-O-L-O-G-O-U-S. They are a homologous series. And what is the general formula of alkanes? So the general formula of an alkane is CN, just like the nth term in maths, right? CnH2n plus 2. So if we use this one as an example, we've got 3 carbons, so N would be 3. So that we'd have 2 lots of, so if N is 3, you've got 2 lots of 3, which is 6, plus 2, which is 8. So you'd have C2H8, sorry, C3H8, which follows that C3, 1, 2, 3, H8, 1, 2, 3, 4, 5, 6, and the 2 on the end. So the general formula of alkanes, Cn, H2n plus 2. So that's a quick quiz over. So as I started off with, so today we're talking about alkenes. So alkenes are another example of a homologous series. Homologous series. And if you remember from the previous video, a homologous series, they all have the same general formula. So for alkanes are an example of a homologous series. They all have the same general formula. It's CnH2n plus 2. They differ from their neighbours by CH2 because you've added a CH2 to make the chain longer each time. They show a gradual variation in physical properties, so like their boiling points gradually increase as you add more carbons, and they have similar chemical properties, like they all catch fire, they all do the same sort of reactions. So the alkanes were an example of one homologous series. Alkenes are another, which is what the focus of today's video is going to be on. So if we look at, let's pick one. If I pick ethane, so the eth part, if you remember from before, methane 1, ethane 2, MEP B, methane, ethane, propane, butane. So eth for 2, and that was what I talked about in the quick quiz. 1 is meth, 2 is eth. So if it's got 2 carbons, it's eth. And the reason it's got an ane after it, it's ethane, is because it's an alkane. So if you look at alkenes, you would have eth if it had 2 carbons, so it's eth because it's got 2, but it's called ethene because it's an alkene, so it's called ethene. So if I directly compare ethane with ethene, so ethane, it's got 2 carbons. We know carbon's got to have 4 bonds, so 1, 2, 3, and that one's 4. And then this carbon needs 1, 2, 3, and that's its 4. Oops. And that's its 4th bond. And then we'll add in the hydrogens. 1, 2, 3, 4, 5, 6. Because this has the general formula, so they are CnH2n plus 2. So ethane is C2H6. And we talked about this is saturated. It's only got single bonds in it, so it is saturated. Ethene has a double bond between carbon and carbon. So we've got a double bond there, and each carbon needs to have 4 bonds. So this one's got 2 already, so it needs 2 more. So a hydrogen there and a hydrogen there, because these are hydrocarbons, so they contain hydrogen and carbon only. So if we count the bonds, hydrogens have all got 1 bond as before, and carbon's got 4 bonds. 1, 2, 3, 4. And then this carbon's got 4 bonds. 1, 2, 3, 4. And so the formula for ethene is C2H4, because alkenes have the general formula CnH2n. This has got the plus 2 because it's got 2 extra hydrogens. This one doesn't need the plus 2 because it's got the double bond. So ethane and ethene, what have they got in common? They're both called eth because they've got 2 carbons. This is ane because it's an alkane. This is ene because it's an alkene. So alkanes, methane, ethane, propane, butane, you know, all of those, like octane, decane. Alkenes, ethene, propene, butene, you can have octene, like those sorts of things. They've got the difference is they've got a double bond. And that's really important. So the thing the double bond in alkenes is what we call the functional group. Now, don't get too hung up on this. You do need to know this term, but you don't need to know it in great detail. It does come up a lot in A-level chemistry. So the functional group for an alkene is C double bond C. That's what makes it an alkene. We'll learn a few others, but not for a little while. Just as an example, the functional alcohols are another homologous series, and an alcohol functional group is an O bonded to a H. So if I drew this one, H, 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 H. This, there's no functional groups there, it's all just C's and H's, and so this one, and all single bonds, so this is an alkane, and we know it's going to be ethane because it's got 2 carbons. So this, ethane. If I was drawing an alkene, we go, right, functional group C double bond C, and then H, 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 H. So this one, it's got 2 carbons, meth, eth, and it's an alkene. So this one is ethene. And now I'll draw 2 carbons again, C, C. This time I'm going to put an OH on it. So that is an O bonded to a H. You could draw it, that's just an abbreviated lazy way of drawing it, right? You could draw it as an O bonded to a H. That's what that is. But kind of the convention is you draw it as an OH. So it's an oxygen bonded to a hydrogen. So now we fill in the rest with H's. And this, you see it's got an OH. An OH makes it an alcohol. So the name for this, it's got 2 carbons again, meth, eth, so we call it ethanol. And the fact that so it's eth because it's got 2 carbons, and the anol bit, the ol, is because it's an alcohol. So the functional group is just what makes something, it controls what homologous series it belongs to. So alkenes have this C double bond C. And they are unsaturated. So we learned before that if something's going to be saturated, it means it's only got single bonds. This has got a double bond between a carbon and a carbon, so it is unsaturated. And I know this is a bit of a cheesy way of remembering it, but we've got Alkane has a single E, so it's single E because they've got single, can't spell, single bond, and they are saturated. Alkane, single E, single bond, saturated. And then we've got alkene, which is double E. I know it's not like a double E like EE, but it doesn't quite fit, but we'll go with it. Alkene, double E, because there's double bond. And if there's a double bond, it means it is unsaturated. So alkane, single E, single bond, saturated. Alkene, double E, double bond, means it's unsaturated. And you need to know, as before with alkanes, where you need to know the first 4, methane, ethane, propane, butane, you need to know the first few alkenes. Now, there is no such thing as methane. And it makes sense if you think about it, because I said my rule before was MEP B, because you've got meth, eth, prop, and bute. So meth has got 1 carbon, eth has got 2, prop has got 3, and bute has got 4. Well, if meth's got 1 carbon, so 1 carbon, and alkenes have to have a carbon-carbon double bond, well, if you've only got 1 carbon, you can't have a double bond. So there is no such thing as methane. You have to have 2 carbons to have the carbon-carbon double bond. So there is no methane, so it means the first one is ethene, which I've already drawn a couple of times today, but I'll set it out just so we can see them more. So C, C, H, 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 H. So it's C2, H4, and it is ethene. Ene because it's an alkene, eth because it's got 2. So the next one is going to have 3 carbons, so it's going to be propene, prop because it's got 3 carbons, ene because it's an alkene. So 3 carbons, 1, 2, 3. We need to stick a double bond in there, so I'll stick the double bond there, and then we go, how many bonds has this carbon got? It's got 2 so far, it needs to have 4. So another one there, another one there. So it's got 1, 2, 3, 4 bonds. Do the one on this end. It's only got 1 bond at the moment, it needs to have 4, so it needs a H, a H, and a H. So it's got 1, 2, 3, 4, which works. This is the bit everyone gets wrong. If you look, this carbon already has 4 bonds, already has 3 bonds. Already got 3 bonds. 1, 2, 2 from the double bond, and 3 from that one. So it only needs 1 more hydrogen. It doesn't matter if you draw the hydrogen at the top, or if you choose to draw the hydrogen at the bottom. They're identical. If you imagine you just like turned it over in space, it would be the same if it's top or bottom. But what the most common error people make is where they draw it like that. And if you look, that's actually now got 1, 2, 3, 4, 5 bonds, which is wrong. So I'll take one of them away. So if you look, 3 carbons, C3, and then 1, 2, 3, 4, 5, 6 hydrogens, C3H6. Because if you remember, we said earlier, the general formula for alkenes is CnH2n. So if N is 2, 2N is 4. If N is 3, 2 times N is 6. I'm just going to draw propene a slightly different way. If I had my chain of 3 carbons, if I put the double bond at that end, and then drew this, I'd have my 3 hydrogens there, 1 in the middle, and then 2 hydrogens on this one. H, 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 H. That is exactly the same as this. It's just a mirror image. If I flip that one over, you'd end up with a double bond at the other side. So this is still propene. These two are exactly the same. If you look here, the double bond is between the carbon on the end and the middle carbon. And in this one, the double bond is between the carbon on the end and the middle carbon. They are mirror images of each other. They're exactly the same. So it doesn't matter which way you draw these. Those two are exactly the same molecule. The reason I'm emphasizing this point is because when we get onto the next one, sorry, that's my laptop. When we get onto the next one, which is butene, there are 2 different types. And in fact, I'm even going to go onto a separate page so I can put this next. So if I draw butene, so bute has got 4 carbons. Remember, meth, eth, prop, bute. 1, 2, 3, 4. So bute is going to have 4 carbons. So if I draw a carbon chain with 4 in it, there's now definitely 2 different places I can put this double bond. So 1, 2, 3, 4. I could either put the double bond here, or I could put the double bond there. Now I know some of you are thinking 1, 2, 3, 4. Why can't you put the double bond there? Well, I could put the double bond there, but if you look, this is between the carbons on the very end of the chain, and this is between the carbons on the very end of the chain. So these two are, those two are the same, but this one is definitely different. And when you, again, this is mainly an A-level thing, but they've just dropped this little tiny bit of it in here. So if you don't fully grasp it, it doesn't matter, you can just accept it is what it is. But if you are going to go on to A-level, it's worth trying to understand this next bit. We give the carbons numbers in this chain if you're going to talk about this. So this would be carbon number 1, this is carbon number 2, this would be number 3, and that would be number 4. So if I did this again, carbon number 1, carbon number 2, carbon number 3, and carbon number 4. But the number where the functional group is always has to be the lowest one. So you wouldn't start numbering this one from the end, because otherwise you'd have, this would be 3 and 4, and the functional group would be like on number 3 and 4. You start counting from whichever end gives the special functional group on the lowest number. So with this one, if I had the double bond there, you go, right, you start from the end with a double bond. So this would be 1, that'd be 2, that'd be 3, and that'd be 4. So you've got the double bond between number 1 and 2. And here you've got the double bond between number 1 and 2. So these two are absolutely identical to each other. So I'll rub that one out. I will just get rid of these numbers for a second, because they're going to just make the, I'll just start again. So we've got 1, double bond, 2, there we go, that one, double bond, that one, that one. Right, if I fill in the hydrogens, this one needs 3, H, H, H. This one needs 2, 1, 2. Remember, all you're doing is counting up to 4, so it's got 1, 2, 3, 4. This one needs 1, 2, 3, 4, so it's fine. This one, it's already got 3 bonds, 1, 2, 3. So don't make the same mistake I talked about with propene, only needs 1 more. Doesn't make any difference if you go top or bottom. I tend to draw it at the top, but it's exactly the same either way. And this one's got 2 bonds, so it needs just 2 more. 1 and 2. And the name that we give to this one, we call it is butene, but butene isn't specific enough. So what we do is we call it but-1-ene. It's called but-1-ene. But because it's got 4 carbons, meth, eth, prop, bute. So but because it's got 4, ene because it's an alkene, because it's got the double bond, and then the 1 bit is because the double bond is on carbon number 1. Remember I numbered them earlier, carbon 1, 2, 3, and 4. The carbon is on the double bond, the 1-ene, the ene is on carbon number 1, so it's but-1-ene. So now, if I draw the other one, 1, 2, then that was the double bond, and that one. So this one needs 4 hydrogens, H, H, H. This one only needs 1, H. This one only needs 1, H. And we could draw that one at the bottom. it's exactly the same as that. So it's got 1, 2, 3, 4. This one's got 1, 2, 3, 4. This one needs 3. 1, 2, 3. And if you look, so that's carbon number 1, that's carbon number 2. So this double bond is on carbon number 2. So this one is called bute because it's got 1, 2, 3, 4 carbons. 2 ene because the double bond is on carbon number 2. If I did count from this end, that would be carbon number 1, this would be carbon number 2, and the double bond is still on carbon number 2. So it's bute 2 ene. 4 carbons and 8 hydrogens. So they both have C4H8. This one is also C4H8. They've got the same formula, but bute 1 ene is different from bute 2 ene. So the alkenes you need to know ethene, propene, bute 1 ene, and bute 2 ene. But hopefully you're starting to see a bit of a pattern here, because you don't actually have to memorize them all if you just memorize how it works. If you memorize the fact that alkanes end in ane because they are saturated with single bonds, if you remember the single bond saturated, and they end in ane. So if you get asked to, and then if you remember MEP B, so if you got asked to draw propane, you remember, okay, ane means it's an alkane, just got single bonds. Meth F prop, so propane is going to have 3 carbons, 1, 2, 3, all with single bonds. If you get asked to draw propene, you need to remember ene, oh, it's got a double bond, and it's propene, meth F, so I need 3, I need to have a double bond, and then you fill in the hydrogens from there. So there's not as many, it's not as complicated to remember all these. Like later on, and this is a little way down the line, you might get asked to draw propanol, and you need to remember that the ol makes it an alcohol, but prop, it's meth F prop, it's got 3 carbons in it, and I need to draw a chain that's 3 carbons long with the functional group for an alcohol on. That's a separate lesson, but it's more, you don't have to remember all these different things if you remember the patterns of them all. I was going to go through a couple of extra bits, but I think this video's gone on just about long enough. So what I'll do is I'll put the extra bits into the follow-up lesson. But that's your basic introduction to the alkenes.